In this lecture, we will learn the evaluation of double and triple integrals with help of some examples. So let us take our first example. In last lecture, we have discussed how to take the limits corresponding to these variables. So I am not going to detail that thing here. If you have not attended that lecture, the lecture is uploaded on YouTube and the name of the lecture is multiple integrals. So go back and take that lecture first, then come to this lecture. So we know that the inner integral limit will correspond to x and outer integral limit will correspond to y, and because limits are constant, so you have freedom to evaluate the integral with any variable first. So I will integrate in both the ways to show you that the order of integral does not matter if the limits are constant. So number one, we will integrate the x integral first. So x has the limit 0 to, so this is equal to 0 to 1 and evaluate x. So this is x cube by 3 y square plus x square by 2 y plus x, and the limit of x is 0 to 2 and dy will remain. So you got 0 to 1, lower limit is 0, so it is 8 by 3 y square plus 4 by 2 means 2, 2y plus 2 dy. This will, and now you integrate with respect to y. So this is 8 by 3 y cube by 3 plus 2 y square by 2 plus 2y, and the limit is 0 to 1. So the final answer is a upper limit is 1 and lower limit is 0. So all terms will vanish at the lower limit. So we get 8 by 9 plus 1 plus 2 means 9 is 37. This 3 and 9 3 is 27, and that plus 8 35 by 9. 35 by 9. So this is our answer, and now we will evaluate the y integral first to show that the same answer comes. So this evaluate the y integral first. So 0 to 2 will remain. So x square and y cube by 3 plus x y square by 2 plus y, and the limits of y are 0 to 1. I have already shown 1, dx will remain. So you get 0 to 2, upper limit is 1. So x square by 3 plus x by 2 plus 1 dx, and now evaluate this as usual. So you get x cube by 9 plus x square by 4, this is 2, and plus x, limit is 0 to 2. So the final 8 by 9 plus 4 by 4 plus 2, and finally we have again 35 by 9. We take the next example. Evaluate 0 to 1, 0 to x e to the power y by x dy dx. And we have already discussed in earlier lecture that when variable limit is there, the variable limit corresponds to different one means limit is in x, so it will be limit of y. So this integral correspond to y and this integral correspond to x. Even if we write 0 to 1 and 0 to x e to the power y by x dx dy, still this limit will correspond to y because limit appears in terms of x and this limit will correspond to x. So we now evaluate it. Solution. So as we have already discussed in previous lecture that variable limit should be evaluated first. So first we will integrate. Here we have restriction that variable limit integral is evaluated first. So first we will evaluate with respect to y because limit of y is variable. So this is equal to 0 to 1 and e to the power y by x integrated with respect to y gives you x e to the power y by x and the limit is 0 to x then dx. So just put the limit 0 to 1, x take x outside the bracket, and when upper limit x by x is 1, so e, and when lower limit then y, you will put 0 for y, so e to the power 0, this is e minus 1 and dx, and now e to the power minus 1 is constant, so easily you can integrate to get 1 by 2 e minus 1. We take another example. Evaluate 0 to pi 0 to a into 1 minus cos theta r square sin theta dr d theta. Here again you should observe that inner integral has variable limit in terms of theta, so the limit is of variable r, so this limit is of r and 0 to pi is for theta, so we will evaluate r integral first, means first the integration will be done with respect to r, so this will become 0 to pi and r square will give r cube by 3 and the limits are 0 to a1 minus cos theta and then sin theta d theta will remain, so we will get this is equal to 0 to pi and upper limit a into 1 minus cos theta whole cube minus lower limit 0 and that by 3 and then sin theta d theta. So this will come of the type 0 to 1 by 3 can be taken outside and even a cube can be taken outside. So we will have 1 minus cos theta whole cube sin theta d theta, and now you need a substitution. So let minus cos theta is equal to t and this gives you sin theta d theta is equal to dt. So you can see that integral 1 minus cos theta whole cube sin theta d theta becomes integral 1 plus t whole cube dt, and this is 1 plus t to the power 4 by 4, and that means 1 minus cos theta because t is minus cos theta, so this is 1 minus cos theta to the power 4 by 4. Now put this integral in the earlier one, so we get from here this is equal to a cube by 3 and the whole integral 1 by 4 1 minus cos theta to the power 4 and limits are 0 to pi. So when you put the upper limit cos theta cos pi is equal to minus 1, so minus minus plus, so it will become 2 to the power 4 and at the lower limit cos 0 is 1, so 1 minus 1 will become 0. So you will get a to the power 3 by 12 into 2 to the power 4. So you can simplify this, and this will come out to be 4 by 3 a cube. So this is how we integrate double integral with variable limit and constant limits. Now we will learn triple integrals. So in triple integrals, we will also learn step by step. First, an integral with all the constant limits. So example 1, evaluate the integral with limits 0 to 1, 1 to 2, and 1 to 3 x square y z dx dy dz. So as we already know that all the limits are constant, so order of integration will be followed. So this limit 1 to 3 will correspond to x, 1 to 2 will correspond to y, and 0 to 1 will correspond to z. So now we will evaluate this. So any of, as we have already seen, you can start evaluation with any of these first, but also observe that because all the limits are constant, so we can separate the terms directly. So we can integrate 0 to 1. This 0 to 1 limit is for z, so we can write z dz into 1 to 2. 1 to 2 limit stands for y, so we can write y dy into 1 to 3 stands for x, so x square dx. So you can directly do in this way. So this will z integral will become z square by 2, so this is 1 by 2. Y integral will become y square by 2, so this is 2 square minus 1 by 2, and x integral will become x cube by 3, so 3 cube minus 1 by 3. So you will get 1 by 2, and 4 minus 1 3 by 2, and 3 into 3 cube means 27 minus 1 26, 26 by 3. So this 3 will cancel 3, and 2 will cancel 26, so you will get 13 by 2. Now take the next example. Next example, and this evaluate 0 to 1, 0 to 2, 0 to 1 xy plus yz plus zx dx dy dz. So we already know how to take the limits for corresponding variables. So let us start evaluating. So first evaluate the x integral, and you can evaluate any one first because all the limits are constant. So this is 0 to 1, 0 to 2, and evaluate x. So this will be 1 by 2 x square y plus xyz plus 1 by 2 x square z, and limit is 0 to 1 dy dz. So we get 0 to 1 y square by 2, sorry, y by 2, y by 2 plus yz plus z by 2 dy dz. Now again you can evaluate anyone first, either y or z. So let us evaluate first with z. So the limit is and 0 to 1, 0 to 2. So the limit is 0 to 2, and we want to evaluate with respect to z first. So 1 by 2 yz plus 1 by 2 yz. This z will integrate and give z square by 2. So plus 1 by 4 z square, and the limit is 0 to 1 of z. So we will get 0 to 2 y by 2 plus y by 2 plus 1 by 4 and dy. Now evaluate with respect to dy with respect to y. So you can see that this y by 2 plus y by 2 is just y. So integral will become y square by 2 and 1 by 4 y. Put the limit from 0 to 2. So this 2 into 2, 4 by 2 means 2 and plus this 1 by 2. So we have 5 by 2. This is our answer. So now we will take one more example. Evaluate 0 to log 2. Log in natural log unless and otherwise basis is specified. Then 0 to x and then 0 to x plus log y e to the power x plus y plus z dx dy dz. Again, remember that we discussed when the limits are variable, they are assigned to x and y or z systematically. Means this limit in the interior integral limit is in terms of x and y, so this limit is assigned to z, means this is z integral. Then middle one, this is limit in terms of x, so this is y integral. And mandatorily you have to integrate the variable integrals first. So the most variable means containing two variable is the interior one, so we will first integrate with respect to z first. So first integrate with respect to z. So first write this as 0 to log 2, 0 to x, 0 to x plus log y e to the power x plus y and e to the power z dx dy dz. Now integrate the e to the power z and put its limits. So we will get 0 to log 2, 0 to x and e to the power x plus y will remain. E to the power z will integrate to e to the power z and limits will be 0 to x plus log y. Then dx dy will remain. Now put the limits, so 0 to log 2 and 0 to x e to the power x plus y and we have e to the power x plus log y minus e to the power 0 is 1 dx dy. This can be further simplified. 0 to log 2, 0 to x e to the power x plus y and this will become e to the power x and e to the power log y means y. So y minus 1 dx dy. Now we will further write this as this is equal to 0 to log 2, 0 to x y e to the power 2x e to the power y minus e to the power x e to the power y. In order to integrate easily, we have just opened the brackets in the last equation, so dx dy. Now see that variable limit is x, limit appears in x, so it is limit of y, so we will integrate y integral first. So now integrate 0 to log 2, 0 to log 2 and y e to the power y, because e to the power x is constant, this term will remain constant during the integration with respect to y. So y e to the power y will be integrated, or let me write one more times, e to the power 2x then y e to the power y minus e to the power x e to the power y. So you have to integrate these. So let us integrate term by term. So 0 to log 2, this e to the power 2x and y to the power y will integrate to y minus 1 e to the power y and minus e to the power x, e to the power y, the overall limit will be 0 to x dx. So put these limit and we get 0 to log 2 e to the power 2x x minus 1 e to the power x plus 1 minus e to the power x e to the power x minus 1, upper limits and lower limits. So this dx, now this just appears in terms of x, so you can simplify this also. So we can write it, this is equal to 0 to log 2. You can also integrate now on your own because this is just the integral of one variable. So we can simplify it to x minus 1 e to the power 3x plus e to the power 2x minus e to the power 2x plus e to the power x, and you can see that the terms e to the power 2x e to the power 2x will get cancelled. So the remaining is 0 to log 2 x minus 1 e to the power 3x plus e to the power x. So now you can easily integrate it, and the answer is x minus 1 1 by 3 minus 1 by 9 and whole e to the power 3x plus e to the power x. The limit for the whole is 0 to log 2, and after simplification you will get 8 by 3 log 2 minus 19 by 9. So this is our integral. We learned the double and triple integration in this lecture. In next lecture, we will learn the evaluation of surface area, means area integrals. We will take different problems for different types of surface areas, means surfaces oriented with different angles and different types, and we will find their areas. And after that we will find application of triple integral to evaluate volumes, and that will be in the next to next lecture. So stay connected to see the applications of double integral to evaluate surface areas.